Hello guys, today let us solve a question from network theory that appeared in GATE EC 2023. So in the circuit shown below, the current I is flowing through a 200 ohm resistor is dash milliampere, and they're asking us to find the current through the resistor, and we need to round it off to 2 decimal places. So first let us take a look at the circuit. So if we directly try to set up the equation of KCL and KVL and try to solve it, it will look cumbersome. So what we are going to do is, we are going to use source transformation technique. Source transformation. So what it means, from Thevenin and Norton theorem, we learned that if there is any circuit with some voltage sources, current sources, resistors, and some other linear elements, and there is some load here, some ZL, we can transform this into a equivalent voltage source and a Z Thevenin, right? And we can connect the load ZL. This is your Thevenin's theorem. Similarly, the same circuit in the Norton's equivalent, we can draw it as an equivalent current source, right? So I Norton, and there will be a parallel Norton impedance and then our load impedance ZL. So how are these two circuits related? They are related as follows. Your ZTH is equal to Zn and your VTH is equal to IN into Zn. So from this, what do we get? If we have a voltage source plus a resistor between any two nodes, let's say X and Y, so let's call it V and R, then this is equivalent to writing it as some current I, and this I is given by V by R, and you have same parallel resistance R. So this is what it means, and this is again between nodes X and Y. So now let us come back to this circuit and try to use this. So it will actually simplify our calculations. So first let us try to go from left to right. Okay, so left side we are seeing here there is a voltage source and the resistor. So we can model this as a current source, right? I'll just copy this again and then modify. So I can change this as a current source and a resistor. So what will be the value of current source? It will be 2 volt by 2 kilo ohm. So it will be 1 milliamp, and your resistor is still 2 kilo ohm. So now your 2 kilo ohm are in parallel. So what you can do then? You can combine them, and since they are in parallel, your equivalent will be now equal to 1 kilo ohm. Similarly, this 1 milliamp is in parallel with this 1 milliamp. So you can combine them and write it as 2 milliamp. Okay, now again we want to find the current flowing in this direction. So what we'll do, we'll transform this particular portion and this particular portion into their voltage with resistor form. Okay, so 2 milliamp and 1 kilo ohm, I can write it as 2 milliamp into 1 kilo ohm, which is 2 volt with 1 kilo ohm resistance. And similarly here, the voltage source will be 1 volt, 1 milliamp into 1 kilo ohm with 1 kilo ohm here. And then we have this 200 ohm, and this is the current I, and now we have a closed circuit. So in this I, we can easily find out I is nothing but your sum of voltages in the loop, 3 volt, divided by the total resistance, which is 2.2 kilo ohm. So if you calculate this, you will get 1.36 milliamp as your current. So this will be your answer. So using source transformation, we can easily figure out this.